Okay, so let's do the top one first. Okay, expand is probably the one that most people don't have any issues with. Okay, and again, if you guys remember, we did stuff like 12 times 15 or something like that, right? This is the exact same thing. We're just using that. I'll show you the table method. Okay, or you get the, this is the one with the 3 different methods. You've got 1 is FOIL, 2 is the table, or 3 is, remember what I called like the rainbow method, okay? Or the distribution. That's what it's called. That's its math name, okay? Distribution is its math name, okay? You get to pick either of those 3 and it'll work, okay? Just for the purposes of simplicity, and I think where everybody's at and the speed at what we're going, I think if you wrote the table out, you'd never make a mistake. Okay, so I think if you wrote h plus 3, right, and up along the top, and then you wrote h minus 2, and you fill in the table, you're not going to mess this up. H times h squared. H times 3, 3h. Negative 2h. And negative 2 times 3 is negative 6, okay? Next step is to take your area that you've just created here and write it in a line. Like we're adding it up, right? H squared plus 3h minus 2h minus 6. Collect these 2 in the middle. One h minus 6. Done. Essentially what we've done here, I want you guys to pay attention to what we've done. Okay, we've taken, it's the exact opposite. I took an equation that was written in factored form. I applied the expansion process. And look at, I got a trinomial back, right? What we just finished doing with the man method above, we take something that looks like this and we make it look like this instead. This is what we call factoring. And to do factoring, right, we called it the man method. You're switching back and forth. That's what we're doing. Because both of those 2 forms, as you saw earlier this morning, told us different things. This tells us about x-intercepts. This tells us about the y-intercept, where it crosses each of those axes, respectively. Right? Is everybody okay? Expansion is not really the one that stumps people. It's the man method. Okay.
Ethan had a question.
Oh, Ethan, sorry. How do you get 6 out of 2 and 3? So you're always multiplying, Ethan. Always. To fill in the middle, you always multiply. So what, I'll go up here for a sec. Let's just revisit for fun. We'll just, actually, I'll go down. Just for the sake of, we're not going to make this mistake of adding, because that's a common mistake, Ethan, is we go up, and let's just say we do something, we'll do that question, 12 times 15. Okay, we would break this down into a 10 and a 2, and we'd break this down into a 10 and a 5. Okay, so if I was to do my table method, I'd say, okay, there's 10 and 2. And then I'd say, okay, down the other side to go 10 and 5. Okay, well, how would you fill in the middle? 10 times 10 is 100. 10 times 2 is 20. 5 times 10 is 50. 5 times 2 is 10. And then we just add them up. 100 plus 50 plus 20 plus 10. 0, 5, 5 and 2 is 7, 8, 180. Okay? I only add after I've built all 4 of these pieces in here. Okay, that's the only time I'm adding through this. To actually fill it in, you have to multiply, which is what we did up here. Okay, if we look at positive 3 multiplied by negative 2 is negative 6. Okay. And then it just translates to over here. Okay. So that means our y-intercept for this particular equation is down at negative 6. That's where it crosses the y-axis. Okay. That's a good question. That's a common, I almost guarantee I'm going to see it anyway, but that's a common mistake that people make, is they start adding the last one for whatever reason. They've spent this whole time multiplying, and then they decide to add the last one. Okay. Now, there's only one really other trick that I can throw at you. Okay, and it's when I give you something like this next question. Okay. Some people look at that, I don't know what to do. Well, if you remember, and I talked about this yesterday too, when we did this. If I wrote down something like x squared, we showed that that's the same thing as x times x. If I wrote down x cubed, that's x times x times x. And if I wrote down, I don't know, it doesn't have to be just x. If it could be y to the power 4, that's y times y times y times y. So it's independent of what this is. Doesn't matter. Doesn't matter what variable you're dealing with. Doesn't matter. You could, in theory, I suppose, also put brackets around these, right? And be y to the power of 4, x to the power of 3, x to the power of 2. This is what these mean, right? So I don't care what's inside of those brackets. You see I changed it, right? Doesn't matter. Well, all that's happened in this question over here is I've changed what's inside the bracket. I'm saying that there are 2 of this, right? The same way I said there was 2 of these. Okay. So that's all we're going to do. We're just going to write it out twice. 4x minus 3 multiplied by 4x minus 3. Now this looks like this. So you just do the same thing. We write the table. 4x minus 3, 4x minus 3. You fill it in with multiplication. 4x times 4x, that's 16x squared. Okay, well, let's do the next one. 4x times negative 3 is negative 12x. All right, well, we said do it again. Negative 3 times 4x is going to be minus 12x. And then you're going to say, okay, one more to go. I'm going to fill in this bottom right corner. You say negative 3 times negative 3. That's positive 9. Right? Then just write it out. 16x squared minus 12x plus 9. Looks like I can collect these two here because they're like terms. So I get 16x squared. Negative 12 minus another 12 is going to be minus 24x plus 9. Done. Okay? That's the only other trick I can throw at you. Doesn't matter what that number is, but I'm not going to get crazy. I'm just going to leave it at 2. Okay? There's just be 2 of them, and you can do your expansion process. Okay? I think the table method is, oops, I erased the next. I think the table method is your best way to go. I find it difficult to make a sign error that way, or just an error in general, right? You deal with it one pace at a time. You don't miss anything. There's always got to be 4 things when you're multiplying binomial by binomial, and sometimes you can miss something, and you get the wrong answer. You just forget to do. If you use the rainbow method, you go multiply, and do that, and then just forget that you have to do this one too. That's happens, right? The table doesn't allow you to forget because you're gonna, if you forget, you're gonna have a vacancy somewhere. whether it's in the bottom right or if it's in the bottom, like top left. You're gonna have a box with nothing in it. Then you're gonna go, I need to multiply that to finish it off. Can't forget anything. Okay. Anybody have any questions? The expansion is not that bad. Okay. You just throw them in the table and do the multiplication. The factoring is a little harder one. Okay.